recording this. All right. So today we are going to do our first of 2 labs, and you may be thinking, why do we not have more labs in chemistry? There we go. The course kind of starts off a little slow, you might have noticed. It's like a lot of introductory stuff, and then all of a sudden it's going to throw a ton of reaction stuff your way. So if you're feeling like, wow, this seems not like chemistry yet, it will become more chemistry-like. So we're kind of skipping ahead today. We're going to start talking about moles, which are one of the main concepts of chemistry. And it also will help us review unit conversions. I know a lot of people were struggling with unit conversions. And so we're going to practice doing those. I'm going to show lots of examples. And people who are here in person are actually going to get to do some measuring of mass of some liquids and solids. And then we're going to use the data that they collect to do some math. So hopefully you all had a chance to look at the mole lab handout that I emailed to you. And I'm showing it right now on my screen. Did you guys get a chance to look at it?
I think so.
Okay. Do you want me to print one out for you?
That'd be great.
Okay.
Yeah.
So, let's see. I'm going to print this really quick. I did horrible. What? That's not what I wanted to do. Why isn't this letting me print? Okay, so I might have to print it in a second because I can't seem to figure out. I had to change to Firefox because I got some insane malware on my Chrome browser and I couldn't get rid of it and it was a mess. And so now I'm in Firefox and I don't know how to use Firefox and I don't really like it. So, all right, we're gonna do some background reading here. I'm gonna let you guys vote. Would you like me to read to you or would you like to read independently, in which case we will figure out how to get this printed? Anyone have an opinion?
Either way is cool.
People at home, you want to type something in the chat? You want me to read to you or you want to read independently? Read to us. Okay. I know. I like reading out loud, actually. That's part of why I became a teacher. Okay. No. So the background on the mole. I copied and pasted this directly from Canvas. Because this is going to be a lesson that you guys see later on in the class. I believe it's in module 2. And basically the mole is a unit of sorts, right? So I'm going to read this and then we'll talk about it a little bit more. So because samples of matter contain so many atoms, scientists use a counting unit called the mole, which is abbreviated MOL, even though it's only MOLE. The word mole represents a number, just like the word dozen represents the number 12. The only difference is that a mole represents a much larger number than a dozen. The number of particles in a mole has been experimentally determined in a variety of ways. A device called a mass spectrometer, which can count atoms precisely, was used to determine the number as 6.02214 times 10 to the 23. We will round this to 6.022 times 10 to the 23rd. All right, so 1 mole equals 6.022 times 10 to the 23 atoms. So people who are attending virtually, I'm writing on the board and it's backwards for you. I will take a picture at the end and post that with the video. So do your best to listen, follow along. You can see the writing of the lab. So this is basically the same thing as saying 1 dozen. How much is in a dozen? 12, right? So 12, whatever items you have, eggs or something like that, right? Usually eggs come in dozens. So we're basically saying that 1 mole of something has a lot of atoms, right? If we were going to write that number out, 10 to the 23rd power, let's see. 1, 2, 3. it's that many zeros, right? So a lot. So we obviously don't want to write that out every time, so we're going to write times 10 to the 23. So why might we care about this, right, is probably what you're thinking. Well, we sometimes want to know how many atoms are in a sample of a substance. So we're going to actually learn how to figure that out today. Now, this number is also called Avogadro's number. Sounds like avocado.
Mm-hmm.
And that's because he was the first scientist who really came up with this concept and started trying to count the atoms. So he, and you guys will see people get super nerdy and cult-like about moles, right? There's a mole day. I've already been emailed like 17 times about it by chemistry organizations. And people get really excited. You don't have to get so excited, but I want you to understand the concept and the math. So the molar mass of something, right, is 1 mole of any substance. So we have our molar mass, which is equal to 1 mole. And conveniently for us, the molar mass is also equal to the mass on the periodic table. So I'm assuming here that you guys kind of already know about the periodic table,
Yeah.
right? I know in earth science they mention it, right? In physical science it's mentioned. You probably saw it in middle school. You probably have just heard about it a million times, right? So you will probably remember that part of that periodic table has a mass listed on it, right? So we're actually going to be using the periodic table, and we have one back here on the wall that we'll use if we need to reference that. So the molar mass is determined by the periodic table, blah, 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 blah. Okay, so it allows you to convert between the mass of the sample and the number of atoms in the sample. It's much easier to measure the mass than it is to count the atoms, right? If I gave you a grain of salt and asked you to count how many atoms were in it, good luck, right? Meanwhile, we can measure the mass of the grain of salt, and then we can figure out how many atoms are in it, because we now know this conversion that a mole is equal to this many atoms. Okay, atomic mass, yes, exactly. So we're going to do an example here of kind of how this conversion stuff would work. And I'm going to annotate on the computer and on the board, so be patient with me here as I annotate. And in the future, if anyone wants to volunteer to be my assistant who annotates on the computer for me, you're more than welcome to. So in the lab, I have this example written. Let's do it over here. If we have something that is 3.25 moles, and we want to find out, oh, I'm sorry, there's actually a question that I'm not even reading. I'm just going straight to doing the math. What is the mass of 3.25 moles of fluorine, which has a molar mass of 18.998 grams per mole, right? So molar mass units are going to be grams per mole. That's going to be useful because you guys probably remember from that unit conversion quiz, units are very important, right? Especially when we're doing conversions. If you don't write the units, you're not going to end up converting correctly. So we have some important information. We know that we have 3.25 moles of fluorine, and we know that our molar mass is 18.998 grams per mole. So when we convert this, all we're doing for unit conversions is crossing out the units that we don't want. We want to know how many grams are in a sample of 3.25 moles. So we want to get rid of moles. Well, guess what? This one's pretty easy because it's already kind of set up just from writing it out. But moles are going to cross out here because I have a mole on the top and a mole on the bottom, we assume that this guy here is over 1, right? And now I can do a basic multiplication, 3.25 times 18.998, to find out my final amount of grams. So I set this up by making a table on the computer, but all I did here was take the gram per mole that was given to me in the problem, and I set it up so that I can cross out moles. And I'm left with grams, right? When you multiply 3.25 times 18.998, what do you get? People at home have an advantage because I wrote it already. You get 61.7 grams. Okay, so basically what we just did was, all we did was convert. We knew how many moles we had. We used a mass provided to us on the periodic table, and we were able to find out how many grams are in that sample. Okay. So how does this apply to chemistry? We're going to practice our technique of unit conversions, which I know is everyone's favorite thing that we've done so far. I promise it becomes easier, right, once you practice it, because it's kind of like a new type of math almost. Instead of thinking about like a formula, you're really thinking about eliminating units, which can get tricky. So we're going to practice our techniques for recording mass of solids and liquids. We're going to use a triple beam balance. We have a digital scale, and we have some different substances back there. And then we're going to practice converting those moles, converting the mass into moles and the moles into atoms. So I got to figure out how to print this thing out. What we're going to do is, you guys are going to vote right now if you would like to do an example first of how to do the math and then do the measuring, or if you want to do the measuring first. Okay, I'm hearing example from people here. Okay. All right, everyone else, give me 1 second. I'm going to stop my screen share for 1 moment because I want to try to figure out how to print this thing. Should not be this complicated. Okay.
Hi, I'm Abby. Nice to meet you.
Okay, I figured out how to print it, yay! Okay, sorry, like I said, Firefox is not my, my jam. But malware was ruining my life. Okay, so Abby, if you could, I won't start the math without you. Do you know where the staff room is?
No, I'm still figuring it out.
Okay,
You can tell
you
me.
know where the staff room is? It says staff room outside of it. Okay, well here, we'll all go on a field trip.
Hey, sweet.
Okay, so we're gonna go to the copy machine really quick, virtual attendees. Oh, it's not backwards, it's just too small. Okay, that's good to know, because earlier it looked like it was backwards. Like I said, I'm gonna take a picture and upload that as well, and then I'm gonna try to figure out a better method for using the board. Excuse me. Okay. Great. Somebody might be printing a lot of stuff. So give me 1 second here.
That's crazy.
Do you need one printed too? All right, we're good to go. We got copies. We're heading back. So we're going to do an example first. The example is going to be underneath the data table. What we're going to do is learn about sodium chloride and the moles of that. So if you're following along at home, we're looking at step 2 now for the math. and then we're actually going to go back and do the measuring afterwards, and then you guys will do more math. So the math looks scary, but I promise it's not as scary as it could be. So if we have sodium chloride, which in case you don't know, is table salt. Right, so regular table salt is sodium chloride. And what we did is we're pretending that we recorded a mass for our sodium chloride of 20.2 grams. Okay, so all we did was pour the sodium chloride on a little paper towel, put it on the triple beam balance, we measured it. Okay, so now we're going to solve for moles and atoms. So, to set this up, for me at least, what I like to do when I'm doing unit conversions is I like to think about all the things I know, all the conversions that I already know. So I just erased some of them, but we know that 1 mole is equal to 6.022 times 10 to the 23rd atoms. Right, we're probably going to need to know that. We also are going to need the molar mass of sodium chloride. So can one of you guys take a look at the periodic table and tell us what the molar mass or atomic mass, they happen to be equal, is?
Sodium is 22.990.
Great. Oh yeah, you're right. I have to do these separated first. Sorry about that. So sodium is 28.
2.990.
Wait, 22?
Yeah.
Uh-oh, I wrote this wrong in here. This is exciting. We'll actually have to fix my math. I put 29 in here. So 22.99. Okay. And chlorine is 35 point, we'll round it to 35.5. Okay, so we'll round the sodium as well. We're gonna round the sodium to 23.0, and we're gonna round the chloride to 35.5. So all I did was find those on the periodic table. You could just Google periodic table if you want to check this. And I made a mistake here, which is exciting because now we'll actually have to fix all this math. So we know sodium and chloride separately. That's cool, except that we want to know about sodium chloride together. So how do you think we could find the molar mass of sodium chloride together? We add them, right? It's actually that simple. Yes.
Okay.
Right? So we're going to add those two together to get the mass of sodium chloride. Now, let me ask you this. What if this couldn't exist, right? Because it's not possible, but what if we had 3 sodiums and 1 chloride?
3 sodiums and 1 chloride together.
Exactly, right? So anytime you have multiple of one element, you're just going to add it that many times. So if you had 3 sodiums and 1 chloride, we would do the molar mass of sodium 3 times and the molar mass of chloride 1 time. Right? This is the easiest step, but it also seems so easy that you're concerned that it's not real.
Yeah.
At least for me, I was like, wait, you add them? But that's what you do. So in this case, we're going to be adding 23 plus 35.5. And what do we get? $58.5. So we have 58.5. And what units are these? Does anyone remember? It's grams per mole. So we just found out that we have 58.5 grams per mole in sodium chloride. Okay, so that was kind of a step that we have to do before we can even really look at our data that we collected. Now we go back to the data that we collected. We found out that in our sample, we had 20.2 grams of sodium chloride. And the first thing that we want to do is convert this to moles. So in order to do that, well, let's look at what we know. We know the grams here. Here I see grams per mole. We need to get rid of grams, right? Grams is going to go on the bottom. And moles is going to go on the top. Now in your mind, you might be thinking, can you do that? Of course I can, right? Because this is 58.5 grams over 1 mole. And we know from math, that's the same thing as 1 mole over 58.5 grams. Right? They are equivalent. They're equaling 1 together, so I can flip it. No problem. So I flip here. My grams are going to cross out, and I'm left with moles. Is that what I want? Yeah. So now, instead of multiplying like we did in our previous example, we're going to be dividing. So people who are attending virtually, who probably are listening to me speak and are maybe following along, but could also be like, what are you talking about? Either way, I am not offended. We basically just typed in here that for 1 mole, we know that there are 58.5 grams, right? And the reason that we know that is from math. We know that if we have 58.5 grams per 1 mole, that's the same thing as saying 1 mole per 58.5 grams. You can flip them, right? There's no reason that you can't do that. So in this case, we flipped so that we can actually cross out. How do I get the pencil? Okay. So that we can actually cross out grams as our units, and we're left with just moles. So if we do that division, does anyone want to do that division for us? 20.2 divided by 58.5. You could use your phone or your computer, people at home. Yeah, let's have our one of our virtual attendees do this for us. What is 20.2 divided by 58.5? You could use a calculator if you want. Okay, I'm guessing we don't have any takers. I will do it myself. 20.2 divided by 58.5 equals 0.345. Oh, thank you. We did get some people. You did it at the same time as me, basically. Okay, awesome. So 0.345 is our answer here. 0.345 moles are in our sample. Okay, that was one step. Our second step is to figure out how many atoms are in our moles. So, since I did the math slightly wrong because I read the periodic table wrong, which is surprising. So now we have something in moles, right? And we want to put it into atoms. So we're going to do something similar here, except the opposite, basically. I could write it here. That's right here. Okay. So we have 0.345 moles. And we wrote a conversion about moles in the beginning, right? Moles to atoms. So we know that 1 mole equals 6.022 times 10 to the 23rd atoms. So now guess what? Moles can cross out, and we are left with just atoms as our unit, and we're left with a really simple multiplication here. Just kidding, it's not that simple, right? We have 10 to the 23rd in here. So for this one, it's kind of hard to do on the computer. It's easier if you have a real calculator. If you have a phone calculator and you turn it sideways, at least on an iPhone, you can get the scientific calculator, right? Which can help you do the math on this. If you don't have a calculator, you might want to invest in one, especially if you plan to go to college and you're going to take any math or science in college. I would just invest in one now. I used the same calculator for like 10 years, and then I finally got a new one, and I didn't bring it, and I'm a bad model, but I have a calculator, right? So if you're going to plan to do science or math, I would just invest in a nice graphing calculator even, so that you can use all the features on that. But otherwise, you can use the phone one, right? Or you can access a scientific one on the computer. It's just not as pretty. So we're going to do 0.345 times 6.022 times 10. Oops, I did this wrong. There we go. Wait, how do I even do it on this calculator? There it is. You might have to play around with it because it depends on the type of calculator you have, which one you can type in to get this. And I thought I did 10 to the x, but that doesn't seem to work.
I think I have it.
You have it?
Sure. 2.07759 by 10 to the 23rd.
Okay, 2.0.
7759
Okay.
times 10 to the 23rd.
That seems right. That's pretty close to what I got when I had a slightly different number. I don't know how to do this on my phone calculator. I only know how to do it on my real calculator, but you might have to play around with it. You could also literally type that into Google and it will figure it out for you. So that's how many atoms we have in our sample. And again, just to reiterate this, right? Moles are getting crossed out and atoms are left over. That is the unit that we want here. Okay. Any questions about this math or about unit conversions generally? Okay. I did make a video about unit conversions, and I put it in the how to do unit conversions section in modules. Mr. Ling made a video as well. So if you're still feeling confused about those and you haven't checked out my video, check it out. We're going to do some more. I have like weird sweater fuzz on me. We're going to do more unit conversion stuff in our next virtual session next week. We're going to practice it. So we're going to practice it and practice it and practice it. So if you're still feeling a little worried about it, it's okay. You will get it. All right, so that's the math. Really just two conversions here, going from grams to moles and then going from moles to atoms. That's it. You could do it all in one step, right? So if you wanted to go from grams straight to atoms, you could set that up. By the way, I make these like T things. That's how I learned how to do dimensional analysis. Multiplication is implied here. In case you were wondering why I do it like that, that is how I learned how to do it. Okay, so if I wanted to go straight from grams to atoms, I just make my dimensional analysis longer. And I basically did the same exact two conversions. I just did them all in one place, right? I can cross out my grams, I can cross out my moles, and I'm left with just atoms. And if you multiplied all that out, you should get the same answer that we got for atoms. Okay, so Now what we're going to do is we're actually going to record the mass. We're going to do 3 different substances. And I gave you guys 2 easy ones and 1 hard one. So we have calcium chloride, which is CaCl2. I don't remember if it was Ca2, but definitely not. And we have glucose. And we have water. Those are going to be our 3 substances. So calcium chloride is a salt. It's road salt, so it's typically the kind of salt used to dissolve ice, right? It looks super weird. It can also be used to absorb moisture. So we will look at it in a second. Glucose is sugar, right? That you probably eat or have eaten today maybe. And then water, hopefully we all know what water is. H2O. So the hardest part is going to be to find the molar mass of these guys. Because for glucose, you're going to have to do 6 carbons, 12 hydrogens, and 6 oxygens. Right? That's going to be the most time-consuming one. Just be happy I didn't pick acetic acid vinegar because that one's really long. Okay. So we're going to move over to our lab area now so that we can actually do some measuring. And people at home, we're going to try to make this bigger so that you can see. Let's see. Did that make my screen bigger to you guys? I hope so. I don't see it as the biggest one, but I'm assuming it is. Okay. So we have our triple beam balance here. Very fun tool. We have a digital scale, which is way easier to use. We have some graduated cylinders here to measure the water's mass. And then we have our substances. So our calcium chloride. Right, we don't really need to wear gloves to work with these materials because they're completely harmless. I do have gloves if you would like to wear gloves. But calcium chloride looks like that. Little balls of white. Pretty cool.
Yeah.
Right, so that is road salt there. Definitely not the kind of salt we like to eat. And then we have glucose, which, as you can imagine, looks like sugar, right? Because that's what it is. So we got our glucose here, and then we're also going to be using water. So to measure the mass of this, you guys are going to be using a little piece of paper towel as the base so that you're not just putting it directly on the balance. So you might want to weigh the paper towel first. It might have a negligible mass, meaning that it's so small it doesn't pick it up, in which case that's fine. You could just put the substance straight on. If we were using a cup or something like that, you would definitely want to make sure you measured the mass of the cup first. So people at home, you're going to be watching as we measure, and you could be calculating the molar mass of calcium chloride, glucose, or water, because that would be really helpful to us when we're done with the measuring. So all you're going to do is use a periodic table, Google periodic table, find one, and look up the atomic mass, which is the same thing as the molar mass, and start adding. All right, so I'm going to give you guys, let's see, who would like to try the triple beam balance? Okay. Do you have a preference for the substance type you would like?
No.
Okay.
Fancy Jack.
Yes.
Oops, sorry about that. Calcium chloride rolling off the table. Okay, and then we'll also have our glucose sample and our water sample. So this worked out well. There's 3 of you, so you can each do one. You can all do each of them if you want. It's up to you, but we'll have our glucose sample here. And then water is going to be a little more complicated. You are going to have to measure that empty cylinder first. Fill it up with some water. I'll fill it up for you. It doesn't matter exactly how much. And then weigh it again and subtract out the mass.
Right.
So who wants to take on the subtraction?
Get out the way.
Okay. You're like, yay, subtracting. Okay, so then here's a glucose for you. If you want to use the digital scale, we'll plug this guy in.
It's looking like it's almost exactly 10 grams.
Wow, that's amazing. I hope this plug works.
A little less.
Hopefully it does.
Oh, just turn on.
Oh, good.
Hey.
Yes. Okay. So, oh wait, first. We want to take this off first because we're going to
Right.
zero it first. Really? Really? Okay. Wow, the digital scale is giving me issues.
Yeah.
Okay, so we are recording our masses. We just found out that our mass of calcium chloride is
A little over 10.
10. Let's see if we can show this.
Let me know.
Yes. Oh, yes. Beautiful triple beam balance. Okay. And then our glucose mass is 6.5. Again, we are assuming the paper towel barely weighs anything, which it really does. We could weigh it on the digital scale to see exactly how much it weighs if we want to be super, super accurate. It looks like it weighs about 0.6 grams. So it's up to you guys. Should we take out the paper towel, you think?
Sure, that'd make it, it's 0.5 now, so it'd just be 6 then.
Okay, and that it would make yours 9.5. Okay, so I'm gonna go back to sharing my screen. Janie Mae is working on water for us. Which one would you like to use, the digital or the triple beam? Cool, go ahead. We're gonna just fill in the data table here. So the mass of our calcium chloride is 9.5 grams. The mass of our glucose is 6 grams. And we will find out the mass of the water here in just a moment. So it looks like, if you guys looked at this, like eyeballing it, they look like the same amount, right?
Yeah.
Almost pretty close. I just poured it, right? Because the exact mass here is not what's important. What's important is the math. But they look like similar amounts. So we're going to find out how many atoms are in each of these samples, and we'll see which one has more atoms. But what do you guys think? Who will have more atoms, glucose or calcium chloride?
Glucose maybe?
Yeah, I think glucose too, because there's way more elements in it, right? We
Yeah.
have 6 carbons, we have 12 hydrogens, and 6 oxygens. So yeah, the amount doesn't matter just because we're literally taking a sample and measuring it so we can see the mass so that we can find the moles and the atoms. In other labs, there might be things where it's like, find 10 milligrams or 10 grams of something. In which case, then we would want to be super precise, make sure we have exactly that amount. In this case, I literally picked a random amount and handed it to them to measure, right? Because all we're doing is finding a mass that we can then use to do moles and atoms. Okay.
I got 65.7 grams for water.
The water is 65.7 grams. Uh-oh. Yes, you guys should write this down as well. Okay, so that is our 3 masses that we just recorded in the lab. Now what you guys are going to do to finish out this lab is do the math. You're going to convert your masses into moles and then into atoms, right? And you can always look down at the example here of how to do that. You're gonna show your work, right? You could either do it on paper and take a picture. That's totally fine. You can make a box like I did to set up the dimensional analysis in like a table. That's fine. However, feels more comfortable to you. And then what we're going to do for these virtual sessions is I'm going to give you guys a code word. I did this before and I realized I don't have to grade that quiz, so I have to go back and add those points, which I'm going to do today. So there's going to be a code word, and if you know the code word, you can get full credit on the lab, right? 100. If you don't know the code word, you are going to get 10% off. which isn't that much. And eventually, as we go more into the year and people know that the virtual sessions are required, it will be 20% off, right? So the code word for today is bacteria, which I'm gonna have to edit that out of the video because I didn't mean to say it. But that's the code word. So when you turn in your lab, please include the code word somewhere. You can put it at the top, you can put it at the end, wherever. I'm gonna look for it. If I can't find it, right, obviously, then we can have a discussion about where you put it. Don't share it with other people in the class who weren't here because they're not VIP enough to know the code word, so they will get 10% off of their grade. Okay, so that, actually, you know what? I'm gonna change the code word since I said it and I don't wanna edit this. New code word.
Okay.
I will tell you guys when I'm done with, I'm gonna stop the recording in a second. New code word is this. I put it in the chat. I hope I spelled that right. Did I spell that right, guys? If I spelled it wrong, I hope you know what I meant. Okay, so that is a new code word. Bacteria is not the code word. If you put bacteria, then I will still take 10% off. Okay. Any questions from people at home? Because all that's left is the math. I'm gonna be here helping people in person with the math if they want, or they can leave. Otherwise, this lab you're gonna turn in and you're gonna include that code word. And that's pretty much it. So questions from people at home, pop them in the chat if you've got them. Otherwise, you can get started on that math. I'm gonna take pictures of what I wrote on the board and upload that as well as this video so that you can watch it again if you need to, especially if you want to go through the math again. Okay. All right, last call for questions. Okay. Well, thank you for everyone who attended virtually, and please feel free to email me if you have additional questions or you have a personal question. And I will see you guys next Friday.